Hello and greetings to everyone. We are going to start with topic 1. The theory of quadratics. And this is the first topic we are going to start with for high school mathematics. First thing, we are going to start by defining a quadratic equation. We know that a quadratic equation is an equation in which the highest power of the variable, when we talk of the variable, that means the unknown, what we are to solve for is 2. That's the quadratic equation. It is an equation of the form, I'll write it down with a red pen, ax squared plus bx plus c equal to 0 for e not equal to 0 and a, b, c being constants. That means it belongs to the set of real numbers. Now I will explain why a should not be equal to 0. If for example a is 0, we know 0 times, take 0 times x squared plus bx plus c equal to 0. 0 times x squared will give us 0, and we'll simply be left with bx plus c is equal to 0, of which in this case the highest power of the variable x is 1, and this gives us a linear equation which is different from a quadratic equation. So you take note, that's why a must be different from 0. Now we note the following, take this down, note you take the first hyphen by margin, an expression of the form ax squared plus bx plus c. You see that in this case there's no equal to 0 for e not equal to 0 and a, b, c being constants, it belongs to the set of real numbers, is called a quadratic expression. For a quadratic expression, we have no equal to sign. For a quadratic equation, we have an equal to sign. So you take note of that. Most often, students usually confuse between a quadratic equation and a quadratic expression. E.g., these are examples of quadratic expressions. Negative 3x squared plus 7x plus 4 is the first one. Next one, x squared minus 10x minus 11. This is another example. We take the next hyphen, a function of the form f of x is equal to ax squared plus bx plus c, or if you have f such that x is mapped onto ax squared plus bx plus c. I will underline these functions. For e not equal to 0 and a, b, c belonging to a set of real numbers is called a quadratic function. Now let's take some examples of quadratic functions, e.g. f of x is equal to 4x squared minus 25. This is an example. Next one we have f maps x onto x squared plus 10x plus 4 is another example. Now we take I by the margin, solving quadratic equations. We are going to see how to solve quadratic equations. Write this down. Quadratic equations can be solved by the following methods. Take the first one by factorization. So when you hear factorization, means in this case we are going to make good use of factorization. And after factorizing the quadratic expression, we are going to equate the factors to 0 and we solve for the unknown. Let's write this down. To solve a quadratic equation of the form ax squared plus bx plus c equal to 0 by factorization, find two numbers n1 and n2 such that take note of this, such that n1 plus n2 is equal to b, and n1 times n2 is equal to e times c. That is we take the quadratic equation, which is ax squared plus bx plus c equal to 0. After getting the two numbers n1 and n2 such that they verify these two conditions, the next step will be for us to replace b with n1 plus n2 times x plus c is equal to 0. The next step will be for us to expand this bracket. n1 times x will give us n1x plus n2x plus c is equal to 0. Then next thing, we are going to take this first pair, we factorize what is common. We take the second pair, we factorize what is common. Then after performing the factorization, we equate the factors to 0 and we solve for x in the linear equation. So here we factorize and here we factorize. We take examples. Solve the following. Quadratic equations by factorization methods. Here we have x squared plus 6x plus 5 is equal to 0. B, we have 2x squared plus 5x plus 2 is equal to 0. C, we have 25x squared minus 4 is equal to 0. D, we have 7x squared minus 14x is equal to 0. We are going to take down solution. First, for us to answer question E, we have x squared plus 6x plus 5 is equal to 0. In this case, you'll see that the coefficient of x squared is equal to 1. For this case, for us to solve this quadratic equation by factorization, we are going to start by writing the factors of the constant term. That means a term which is independent of x. And here the constant term is 5. We write out the factors of 5, both the negative and positive factors of 5. First, we have negative 5, followed by negative 1, next 1, and lastly 5. Looking at the set of factors of 5, we need two numbers from this set such that their sum is equal to 6 and their product, the same numbers, is equal to 5. Looking at this set, we see that if you take 1 plus 5, it is equal to 6. If you take 1 times 5, it is equal to 5. Next, what we are going to do is x squared plus, here we are going to replace 6 with 1 plus 5. X squared plus, brackets open, 1 plus 5 times x plus 5 is equal to 0. This will give us x squared plus, next we are going to expand this bracket here. 1 times x gives us x plus 5 times x gives us 5x plus 5 is equal to 0. We are going to take this first pair, the second pair. Here we are going to factor out what's common. We know that x squared is equal to x times x. So here with x is common, we are going to factor out x. X times x will give us x squared plus, we know x times 1 remains x plus, we go now to the next pair of terms. Here you see that 5 is common. If you factor out 5, we know 5 times x gives us 5x plus 5 times 1 gives us 5 is equal to 0. Now we are left with two terms. This is the first term, this is the second term. And looking at the two terms, you will notice that x plus 1 is common. We are going to factor out x plus 1 times x. If you take x plus 1 times x, it gives you x times x plus 1 plus, if you take x plus 1 times 5, it gives you this. We equate it to 0. At this level now, you're going to see either x plus 1 is equal to 0 or x plus 5 is equal to 0. We make use of or because x cannot take two values at the same time. Solving this linear equation, x here will simply be equal to -1. Or solving this other linear equation, x will simply be equal to, if you transfer positive 5 this way, it becomes negative. X equal to -1 or x equal to -5. It simply means if you replace x here with either -1, you simplify, you obtain 0. Or if you replace x here with -5, you simplify, you obtain 0. That's what it means. We move now to the next question, question B. Question B, we have 2x squared plus 5x plus 2 is equal to 0. In this case, you see that the coefficient of x squared is 2. It is different from 1. For us to answer this question, we are going to start by finding two numbers such that when we add the two numbers, we are going to obtain 5. And when we multiply the two numbers, we are going to obtain 2 times 2, which is equal to 4. You will notice that the two numbers will simply be, if you take 1 plus 4, it gives us 5. If you take 1 times 4, it gives us 4. Now, we are going to write this down, 2x squared plus, here we are going to replace 5 with 1 plus 4. times x plus 2 is equal to 0. This will give us 2x squared plus, we are going to expand this bracket, 1 times x gives us x plus 4 times x gives us 4x plus 2 is equal to 0. Looking at these two terms, you'll see that x is common. We're going to factor out x. X times 2x will give us 2x squared. Take note of this. Plus x times 1 remains x. Plus, looking at these two terms, you'll see that 2 is common because 2 is the highest common factor of 4x and constant 2. We open our bracket, we know 2 times 2 gives us 4. Then we are going to attach x to this 2. 2 times 2x gives us 4x. Plus, we know 2 times 1 remains 2 is equal to 0. Now we have two terms. And looking at the two terms, you'll see that 2x plus 1 is common. We are going to take 2x plus 1 times x plus 2 is equal to 0. So at this level, we are going to say either 2x plus 1 is equal to 0 or x plus 2 is equal to 0. Here, this will give us 2x to be equal to, we are going to transfer positive 1 to the right hand side, which becomes negative 1. Or x will be equal to, we transfer positive 2 to the right hand side, which gives us negative 2. Next, we are going to divide both sides by the equation of x, which is 2. This will give us x to be equal to negative a half, or x is equal to negative 2. We move now to question C. For question C, we have 25x squared minus 4 is equal to 0. For us to answer this question, it is very easy for us to perform factorization here. We know 25 is equal to 5 times 5, which is equal to 5 raised to the power 2. We know 4 is equal to 2 times 2, which is simply equal to 2 raised to the power 2. We are going to replace 25 here with 5 raised to the power 2. This will give us 5 raised to the power 2 times x raised to the power 2 minus 2 raised to the power 2 for 4 is equal to 0. This will give us, we know if we have a raised to the power n times b raised to the power n is simply equal to a times b, all is raised to the power n. So we are going to apply, this will give us 5 times x, all this raised to the power 2 minus 2 raised to the power 2 is equal to 0. Here, you'll see that this is a difference of two squares. And we know the factorization of a difference of two squares. For example, if we have a squared minus b squared, the factorization is simply equal to a minus b times a plus b. This will give us 5x all this squared minus 2 squared to be equal to, let's perform the factorization of this. Compare, a is 5x, b is 2. We are going to replace them here. So this will give us 5x minus 2 times 5x plus 2. 25x squared minus 4 equal to 0. Then this will give us 5x minus 2 times 5x plus 2, which is the factorization of this, is equal to 0. Then 5x minus 2 will be equal to 0. or 5x plus 2 will be equal to 0. You will see that these are two linear equations. We need now to solve for x. Then 5x will be equal to, if we transfer negative 2 to the right hand side, it becomes positive, or 5x is equal to, if you transfer positive 2 to the right hand side, it becomes negative. Next thing, for us to get the value of x, we are going to divide both sides in the two equations by 5, which is the coefficient of x. Then 5x divided by 5 will be equal to 2 divided by 5, or 5x divided by 5 will be equal to negative 2 divided by 5. Then 5 will strike up 5 here. We'll be left with x equal to 2 over 5, or here 5 will strike up 5. We'll be left with x equal to negative 2 all over 5. So these are the two values of x. We go now to question D. In question D, we have 7x squared minus 14x is equal to 0. You will notice that in this case, we have no constant term. There is no c. That means the constant term is equal to 0. Here we can easily perform the factorization. The HCF of 7 and 14 is simply 7. I'll write out 7. Between x squared and x, we know x is common. So we are going to attach x to 7, which gives us 7x. It simply means 7x is the HCF of 7x squared, and we are going to ignore the negative sign here, and 14x. We are going to open our bracket. 7x times x, if you take this, 7x times x is simply equal to 7x squared. We put the minus sign. 7x times 2 will give us 14x. We know 7 times 2 gives us 14. Attaching this x, it gives us 14x is equal to 0. At this level, we are going to say either 7x is equal to 0 or x minus 2 is equal to 0. Here, for us to get the value of x, we are going to divide both sides by the coefficient of x, which is 7. Or here, x will simply be equal to, we are going to transfer negative 2 to the right hand side, which becomes positive 2. This will give us x here to be equal to 0 divided by 7 gives us 0, or x to be equal to 2. And we are done with the correction of the examples.